rectangles, rhombi, and square. What do you remember about rectangles, rhombi, and squares so far before we even put anything new up here? What's your basic description of a rectangle? Here.
Parallel sides.
Okay, both pairs of parallel sides and
The diagonals intersect.
they intersect, sure. Good. So just those are things that you know ahead about. What is a rhombus, basically, from what we talked about before? What distinguishes a rhombus from just any old parallelogram? Anybody remember? Okay, since nobody, yep, go ahead. All four sides are equal, good. And a square, feels kind of weird to ask you what a square is, but you can tell me what a square is. Yep.
They have equal sides.
Equal sides, yep.
And 4 90-degree angles.
4 90-degree angles. Is it a parallelogram?
Yes.
Yes, good. Okay, so these are some other special things that are only true about rectangle, rhombi, and squares. So this one happens to be for rectangles. Okay, when you have a rectangle, the diagonals have to actually be congruent. That's what you're filling in here, that the diagonals are congruent. And what does congruent means so which two would be congruent in terms of this picture for the diagonals? Yeah, go ahead.
AC is congruent to BD.
Good, perfect. AC is congruent to BD. Sorry, this came out below. There's some kind of an editing problem on it, but you know where it belongs. So the diagonals of the rectangle are congruent. That means that AC is congruent to BD. Okay, so those are, that's true about rectangles, which would mean that it's also true about squares. Good. Not true about rhombi. Okay, but definitely true about rectangles. Squares are special rectangles, so definitely would be true in there. Okay, everybody has that down? Yes. All right. So with a problem like this, if it says rectangle SPUW, we can take that and we can open up a thing that I can't wait with, and it's hiding on my other screen. I'll do it all the way from here. It will let me do it if I can get along here. You can't see. Let's pull this over. Okay, here we go. Here we go. And we'll paste that up there for us. There we go. So we want to find those values if we know that SU is 3x minus 5 and WT is 5x minus 23. What can we do then in order to find x? What kind of an equation can we set up? Okay, so I have 3 people so far that have been brave enough to answer. Is there anybody who did not yet? How will I set it up? Go ahead.
Are you eating in class?
3x minus 5 equals 5x minus 23. All right, so we've set this up because the diagonals have to be equal to each other, and then we need to do the algebra. You want to run us through the algebra? Yes? Where you do both sides? Subtract 3x, good. So when we do that, we have 2x minus 23 equals negative 5. What would you do next?
You add 23 to both sides.
Add 23, sure.
You get 18 equals 2x.
So we get 18 equals 2x. Hopefully everybody knows, anybody can say it right now, x equals 9. Thank you. So x equals 9 because we know that the two diagonals are equal length. So that means that x would have to be 9 in that case. Question? If you really must. Okay. All right, so there is that. It's right there. It's just near like that. Okay, so I'm gonna put this on pause. Okay, everybody got that down now? All right, cool. All right, so then the actual thing it said to do was take that and then find out SD. So we have to think about that a little bit. We can find out SU, right? It doesn't give us a direct equation to plug in to find SD, but who can help us figure out how would I find SD? Yes, Angela.
You would just plug the 9 back into X for SU.
Cool. So plug the 9 back in to SU. So 3 times 9 minus 5.
22.
22, good. 3 times 9 minus 5, that gives you 22. And if this one's 22, then how long is the other one's here? 11. 11, good. Because it's half as big. Because just because it's a rectangle, and we know that the diagonals are equal, it doesn't mean we can forget the idea that this one is half as big as the whole long diagonal. Right? Yeah. Good job, guys. Nice effort. Okay, while you write it down, bring this up, and I'm going to just pause this. All right, so rectangles. Rhombi have some other things. Okay, when you have a rhombus, there's a special trait in that each diagonal of a rhombus is the first word here, will actually bisect the 2 opposite angles. That doesn't happen in all parallelograms. And it doesn't happen in a rectangle, but in a rhombus, it does bisect. So it cuts the 2 angles, the 2 corners, into 2 equal pieces. Okay, this one and this one are congruent. This one and this one are congruent. So when we're filling in, angle ABD would be the same as angle what? Angle ABD would be congruent to angle what here? CBD? CBD. Good. Angle CDB is a different one. CDB is found in the bottom. So CDB would be ADB. Good. BAC, and I'll show you. BC. BAC would be BCA. And DCA would be BCA. Wait, I think the one before that may have been, but one before was BAC would be DAC. Okay, and actually, I kind of got caught up in the fact that they're also alternate interior angles. So yeah, so that also would be true. But if we're looking specifically, if the bisector rule, we're looking specifically with this one and this one and this one and this one. But because of alternate interior angles also being congruent, it turns out that you have groups of 4 congruent angles, this and this and this and this, this and this and this and this. So it bisects the angles on both corners like that. Okay. But do take the time to write those in and make sure that you have them. I'll put it on pause for the people at home, because you can pause it and write as many times as you want. Hi guys and girls, hope you're having a good time. All right, so another fun fact about rhombuses. We talked about diagonals of a rhombus a minute ago, but the diagonals of a rhombus also are perpendicular. Okay, that again is not something that will happen for your normal average everyday rectangle. It is not something that will happen for your average everyday parallelogram, but this special parallelogram The diagonals are perpendicular, so put the word perpendicular in. They will always make a right angle. And we can use that. In geometry, and we want to keep our eye out for opportunities for there to be right angles. When we get into the next chapter, we're going to be talking about special triangles. And wherever you have a right triangle, there are some special things that happen. And so there are some patterns that we're going to need to discuss as we go over those. All right, now, unfortunately, like I say, there were some technical difficulties, so let me fix that on this. Okay, hold on a second
Rectangle, rhombus.
before we do this, I just need to change this. It's weird when I got the new computer, all of a sudden, all of my
Rectangle,
things got to where they didn't line up properly.
rhombus.
So these are the words that go into that. Okay, if the diagonals of a parallelogram are congruent, so diagonals of a parallelogram are congruent, it's a rectangle. This is kind of restating what we already had.
Rectangle.
If the diagonals are perpendicular, it's a rhombus. And if one diagonal of a parallelogram bisects a pair of opposite angles, it's also a rhombus. So it's just taking those and making them the converses of the statements. But as long as you associate those ideas together, you're good. That congruent diagonals mean rectangle. Got to be a parallelogram though. Yes.
Could it also be a square?
As a matter of fact, it can be, because interestingly enough, a square is a special type of rectangle, and it's also a special type of rhombus. So square fits all of these categories as well.
So if these questions were like on a quiz or a test, would a square be wrong?
A square would be right. Also, more generally, these would also be right. Okay. I'm trying to, like I said, I'm revamping some of the quizzes and tests to make them better. So we have that. Okay, so we need to consolidate our fun facts about the square. Actually, you just saw square, and so maybe that prompted it, but there are special things about a square as well. So we want to list the things that are special about a square. Sierra already pointed out that the diagonals would have to be congruent. They would also have to be perpendicular. They would also have to do a couple of other things. In any parallelogram, what do the diagonals do? They bisect each other. And because it's a rhombus, the diagonals are also going to bisect the angles. So there's these four things. They bisect each other because it's a parallelogram. They are congruent because it's a special rectangle. They bisect the opposite angles because it's also a special rhombus. And they are perpendicular also because it's a special rhombus. Squares have all of those things going on. So we want to be able to do that. Well, you've seen all of the different things. We're going to be going through a problem here now. I want to make sure everybody's got all of the basics, and then we can look at the problem. Now, there are other things that can be added on top of the problem that we have that's coming up, but that's in the next chapter. Those are special right triangles, 30, 60, 90, 45, 45, 90. Some of you may have seen that somewhere in your past, but most likely not. That's coming, but these are with the things that we've already had. So I'm going to do this. I'm going to copy it again and put it on a thing that I can write on. Okay, here we go. Paste it on there. So here we have this. It says it's a rhombus, so that's good to know. We need to know that it's a rhombus. So it's a parallelogram with 4 equal sides. And so we need to find all of these missing angles and things. Okay, so let's just go through. We do not have to go in order, but how about somebody give me something that you know because it's a rhombus. It doesn't have to be the most complicated thing. It can just be something that you know because it's a rhombus about one of those angles. This one's 59. You have to have something to start with, or you're gonna get nothing. Go ahead, Christina, tell me one thing.
Angle 1 is equal to 59 degrees.
Okay, angle 1 is also 59 degrees. Mostly because we noticed that we had like a group of 4 that were all congruent. If you want to think back to reasons that we had in the past, if we know it's a rhombus, we've got 2 congruent sides here, so the opposite sides of an isosceles triangle, the opposite angles have to also be congruent, so that's another reason why that's true. So angle 1 is 59. Is it? 2 is 90. Okay, good. How'd you know that was 90?
Because it's the
Diagonals.
the diagonals always are perpendicular.
The diagonals are perpendicular in rhombuses, so that one's 90. This one's 59. How about you tell me, since you're thinking so hard about stuff and angles and all of that, can you tell me angle 3?
Angle 3.
Mm-hmm.
Yeah, you can come back to me.
Okay, well, let's look at your list. What is true about the diagonal of a rhombus in regards to what it does to the angle here? What does it do to that angle? Read that one.
Bisects opposite.
So it bisects the angle, right? So since it bisects it, what does that mean?
It stops the angle.
Well, it means that, what's bisect mean?
Split it in half.
Split it in half. So if this is one of the halves, what's the other one?
The other half.
The other half, so how many degrees is that?
59.
Yeah, 59, good job. Okay, so this one's 59. Because it bisects those corners. Okay, so 4 might be a little bit harder to find. But not too bad, but we can think about 4. Any thoughts on how you would find 4? What do you think's here?
You have to add the 2 angles that you know together and then subtract it by 1, 2.
Okay, so in this triangle right up here, the upper left triangle. Okay, so we know the 59. What other angle do we know? The 90. So she said we can add 59 and 90. Okay, and then she said subtract from 180. Which is 31. So 31 degrees. Okay, that's a 1. People at home, that's a 1. 31 degrees. All right. Then we need to take a look at angle QRS. So this one, QRS, all the way up here. So it's this one right here. If I'm doing this right. So QRS. Sorry about that. Okay. Terrible. Anyway, how will we find that one then? QRS. So somebody else. I love that she's really with me. Yeah. You don't have to do all that. You could. She said 59, 59, and 31. There's an easier way. Yes. 31 times 2, because if there's 31 here, that means there's a 31 here. Which means that all you have to do is make that into 62. So 31 times 2. 62. Okay, and then
You are a QT.
RQT. Okay, so, sir, so since you had that comment, tell us how
Oh,
to solve
please,
that.
no.
QRT, it's very, RQT, it's very similar
All right. So what you want to do is,
to what we just did.
yeah, what you just did.
What we did is we noticed that in this corner, since this was 31, this one would also be 31, so you'd add them to get this angle.
Yeah.
So down here, this one's 59. I'm trying to find this big angle. What do you think?
So what?
118.
If this one is 59, oh, help out. Yes, sir.
118.
118, how'd you get 118?
I added 59 plus 59.
59 plus another 59, which gives you 118. Because here's the other 59. So altogether, we get 118 degrees. Okay? Yes, you are. All right. So yes, so own that. When you've done something good, you give yourself that little pat on the back and be happy that you got it. Good job. All right. We good? Okay, lots of stuff happening in these. Let's see what we can do about continuing to march on. If two consecutive sides of a parallelogram are congruent, okay, so we're thinking parallelogram.
So it is a rhombus.
And it's a rhombus, absolutely. We do not have to look at this proof part. We're just gonna just do that. And we're just gonna say we have a parallelogram.
That's scary.
Two are congruent, talking it through. If these two are congruent, since it's a parallelogram, the opposite side would also be congruent. This opposite side would be congruent. All of a sudden, we've got a parallelogram with 4 congruent sides. Okay, so we can say, okay, 4 congruent sides on a parallelogram is a rhombus. So we have that. Okay, and we're approaching the end of it. So turn the page. Okay. All right. So basically what we have here is that no matter where you are looking at 2 parallel lines, they have to be the same distance apart, regardless of where you're looking. Okay, and that's what we're aiming for. So if you have a right angle from one line, it will go across and make a right angle to its parallel counterpart. That distance will be the same here, the same here, the same here, as long as you're not tilting those lines. Once you've tilted the lines, then you can't have like a CG, if the G is down here and tilde it, it's not going to be the same length. So the distance between the two has to do with those right angles. And so as long as you're looking at the true distance, which always involves the right angles, then they have to be the same distance apart. And at the very end on your sheet, I just have a summary of all of the facts, what you know about parallelograms, what you know about rectangles, what you know about rhombi. Okay, so those are just a recap of the different facts that are still there on your sheet. I want to make sure everybody gets this written down first, then I'll run through the recap for our people that are away.
We gotta run our best.
All right, so our recap. Our recap is that parallelograms have these traits. parallel opposite sides, congruent opposite sides, congruent opposite angles, and diagonals that bisect each other. Rectangles, because they are parallelograms, the first four are repeats, right? They still have parallel opposite sides, congruent opposite angles, and diagonals that bisect each other. On top of that, the diagonals are congruent. That's why I made it a different font size. Rhombi also have all of the traits for parallelograms, but also that diagonals bisect the opposite angles, and they are perpendicular. And then we had our squares, which was so expertly pointed out earlier, that the squares have all of those traits. And that kind of wraps it up. People who are away, we love you. Hope you're having a great tournament.
Bye.
And yep, everybody say bye.
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 We'll see you tomorrow.
Bye.